right, the purpose of this part 2 is for you to apply what you learned in Unit 4. Now, I understand that Unit 4 has a lot of formulas. We're looking at the log properties, and we're putting those into practice. So I'm not expecting this to be perfect. For the teacher-graded part, I want to see your work. Also, let me just let you know something to be completely transparent, is that I make mistakes, and sometimes I even put mistakes in here to see if you can find them. We need to work together on this, but don't be afraid to try. All right, let me show you an example of how to work this out. So we have the first problem. Let's read through that completely and then pick it apart. Noah may choose between two accounts in which to invest $4,000. Account A offers 2.2% annual interest compounded monthly. Account B offers continuous compound interest. Noah plans to leave his investment untouched, no further deposits, and no withdrawals for 15 years. Which account will yield the greatest balance at the end of 15 years? That's the first question. The second question is, how much more money does Noah earn by choosing this more profitable account? So first, let's find out how much each of these earns, and then we'll find the difference to see how much Noah earns. Now, there was a lot to interpret. I got a lot of interesting questions in email. You need to remember that and try to respect office hours and help sessions as much as possible, because the email is not intended to be used as chat. Even though you feel like it's not taking a lot of time, there are a lot of people trying to crunch and get things done at the end. Much more efficient to come and talk to your teacher. Unfortunately, we are at the end of the semester, so don't wait until the end. Let's try to keep up with things and ask questions as they come up. I will try to have office hours, and I'll send that out to you if I have any availability at all next week. All right, so I've highlighted what we have been given in the word problem. Noah can choose between two accounts in which to invest $4,000. So here's our initial amount. Here's the interest rate. Here's how it's being compounded monthly. So N is going to be 12 because we compound it 12 times per year. And then account B offers continuous compound interest. I also got a question about, are we using the same interest rate? Well, you have to really look into the content. You have to practice with this to know what continuous compound interest is. And these are a lot of word problems, I know. So let's slow down and let's go through this step by step. All right, the formula, you can find the formula in Quizlet for compound interest is A equals P times 1 plus R over N. All of this raised to the N times T. A is the amount that you'll have at the end. P is the principal. That's what you're going to invest. N is the number of times per year. R is the interest rate. And then T is the number of years. All right, so let's identify all of that for account number A. A, we have $4,000 in principal. The rate is 0.022. N is 12, and the time is 15 years. So let's plug that into the formula. A, the amount that we're going to have, equals 4,000, that's the principal, times 1 plus R, the rate is 0.022, over 12, N, raised to the N times T, 12 times 15. So I went ahead and multiplied 12 times 15, that's 180, and then add 1 to 0.22, 0.022 divided by 12, and you get 1.001833333. I use Desmos to do all of this step by step. All right, now we can't multiply this first. You need to raise this to the power of 180. Okay, and this is what we get, 1.38971538. Then you can multiply that times 4,000, and we get $5,558.86. You have to drop off everything that's not a whole penny. We don't round up with money. So it's $5,558.86 after 15 years. That's for account A. Now for account B, we're going to use a different formula, which is also in Quizlet. This is P sub 0 e to the RT. P is the principal. It's the same thing as in the first one. R is the rate, same thing as in the first one. And we don't have an N, so we don't have to worry about that. We do have T. Time is still the same amount, 15. So we're going to substitute in 4,000 times e to the RT. Remember, e is, we have to approximate that, 2.7 something. But I use my scientific calculator for that. So let me just put in here what I used, 2.7183, okay, raised to the 0.22 times 15, that's 0.33. So go ahead and raise 2.7183 to the 0.33 power. We get this number right here, multiply it times 4,000, and you get $5,563.88 after 15 years. Now, I did this a little bit differently with a couple of you because I wasn't using this formula. I was using this formula. I want to illustrate that if you show me what you know, even if you get the wrong answer, you can pass this. This is more about showing your work than getting the right answer. So don't get stressed and get stuck on the right answer. Show me what you know and move on. All right, we don't want to avoid doing this. All right, so we have a difference of amounts. This one looks larger. Subtract the smaller one for a difference of $5.02. So now we can answer the questions. Account B has more money after 15 years. And then Noah will have, need to stop rushing and write in correct English. Noah will have $5.02 more in account B after 15 years. All right, let's go to the second one. I hope all this is showing, but I'll go ahead and try to take a screenshot. Not a screenshot, but I'll try to use Genius Scan and scan in a sample of what I'm doing. All right, we're given log base 5.3 is approximately 0.6826 and log base 5.8 is approximately 1.2920. Evaluate the expressions. Now this one was really tricky, easy to get off, easy to look at it different ways, so don't worry too much about getting the exact answer. In fact, again, I'm not going to guarantee that my answers are correct. We just want to demonstrate that we are practicing the log properties. All right, so we want to evaluate first a log base 5.2 and then log base 5, 75/8. So let me show you what I did. All right, again, it's better to write on paper, write nice and big. Then I don't want Word documents. It tends to squeeze things in, makes it hard to see, hard to manipulate. So use Genius Scan, write on your own paper. I'm going to try to keep reinforcing that, get everybody on board. If there's a reason why you can't or why you need an accommodation, talk to me privately about that. All right, I'm going to try my best to grade whatever you give me. But when we get to the end of the semester or lock date, time starts crunching on everybody. So make it easy for your teacher to grade. to ensure that you get the grade that you deserve. All right, so we're going to look at log base 5.2. Now let's remember they told us what the approximation for log base 5.3 and log base 5.8 are. So I'm going to try to write log base 5.2. I'm going to look at that. It took me a long time to look at this. Log base 5.8, I can write 8 as 2 to the third power. Okay, let me look at the problem again because I get lost with this one. Okay, we want log base 5.2. Okay, so if I can write 8 as 2 to the third power, right here, log base 5.8, I can write that as log base 5.2 to the third. Bring that 3 out to the front. And I think I can see where I already messed up on this one. So we're looking at log base 5.2. We have log base 5.8. So if we divide that by 3, let me go back and do that in my calculator because I multiplied. Normally you would multiply, but because I have log base 5.8, I need to divide this by 3. Let me go ahead. I'm going to let you do that. I'm not going to show you every step. So we'll take this and divide it by 3. So this should be division. Get your answer here. So that's what log base 5.2 would be. So we have to look at what we've been given, try to put it in a base that matches, and use our log properties. All right, for part B, we have log base 5, 75 over 8. And this is what I did. 75, I broke that down into 5 squared times 3. So log base 5, 3, we have up here, 0.626. Okay, I can take, we have the same log, same base. We can scratch through that, bring that out to the front, and multiply. So this is 2 times log base 5.3. We said that log base 5.3 was 0.6826. So 2 times 0.6826 is 1.3652. All right, now we have the quotient property, which we can write as subtraction. Remember, this, I don't have this correct. So we need to go back and calculate this. This is where I'm going to ask you to do your work. All right, so this would be, let me get my calculator out and just see what we get. 1.292 divided by 3. It gave me 0. What am I doing? 1.292 divided by 3 is 0.4306666. And let's see, is that what we have on the top? No, we have this on the top. So we're going to start with this, log base 575, and we're going to subtract 0.4306666. Let me correct this. Repeating, okay. All right, so 1.3652 minus this right here, 0.4 306 repeating. And I got 0.5038, 0.50386668, or something like that, approximately. All right, show me what you know. Don't get bogged down on what you don't know. Think of the part twos that way. Don't get scared of the part twos. All right, question number 3, we have a hive of bees that contains 27 bees when it's first discovered. After 3 days, there are 36 bees. It is determined that the population of bees increases exponentially. So now you know the exponential growth goes kind of slow at first and then it shoots up really fast. After 33 days, how many bees do we have? Express your answer as an exact value. Now I'm going to give you a hint. There is an answer that's been floating around for years on the internet that is not correct. Exponential growth means it's going to be a really large number, larger than probably what you think. All right, round it to the nearest whole number. I'm not going to pick this apart that much, but let's use our formulas. Use your calculator. Show me what you know, and don't stress on what you don't know. All right, the exponential growth formula is in your notes. It's also in Quizlet. It's expressed as n equals n sub 0 e to the RT. Let's pull that apart. N is the final amount. N sub 0 is the initial amount. R is the rate of growth. And T is the number of time periods. All right, so let's plug in what we know. Okay, we don't know the final amount. So we're going to set this up as N equals, the initial amount is 27. We have 27 bees. E is approximately 2.71828, so I wrote that in here for you to see. Our rate, well, we've got to figure out our rate. We have this formula in Quizlet also. Okay, the rate is going to be the ending amount minus the starting amount over the ending amount. So 36 minus 27 over 36, the rate is 0.25 or 25%. It's present minus past over present. So let's put that in our formula. N is equal to 27, which we're just continuing what we did up here, times 2.71828, and then 0.25 times 33. That's R times T. And remember, T is time. We're doing this for 33 days. We calculated the rate, multiplied those together for 8.25. So raise E to the 8.25 to get this number here. Multiply that times 27, and the amount of bees, so the whole number is 103,345. That's not the answer that you're going to find on the internet. I'm just going to warn you ahead of time. That's going to be a tell if you're just going and copying. I understand why you do it, but we need to get out of that habit. You need to trust what you know, put it into practice. Tell me when you don't know, and let me help you. And do not wait till the last minute. All right, question number 4. What is the inverse of the function y equals 9x squared plus 12x plus 4? What domain restrictions are necessary? So don't make this harder than it is. I've seen some really long and complicated answers, but let's just go through this quickly. We've done this enough times in class that I think that this should come back to you pretty quickly if you've been with me in class and you've gone into the course content. So we're going to take this equation and we're going to simply start off by switching the x's and the y's. So here we have an x, we're going to put a y. Here we have an x, we're going to put a y. Here we have a y, we're going to put an x. So we rewrite the equation. Now we need to solve it in terms of y. So I get my Math Papa factoring calculator out. You can find it right at the top of the ICAN. And that factors into 3y plus 2 quantity squared equals x. We're solving for y, so we need to take the square root of both sides. And I'm going to flip these around and once we take the square root of 3y plus 2 squared, these two things are going to cancel each other out. So we'll get 3y plus 2 equals the square root of x. Okay, now we have one last step. Divide by 3, divide everything over here by 3, and y equals the square root of x minus 2 over 3. Now we know that the domain goes with x, and we can't have a negative x. So the domain restrictions, x has to be greater than 0. And that's it for number 4.